Hi, I'm Juliet Regenbaugh, and I'm presenting Image, a deployment framework for creating multimodal experiences of web graphics. And before I begin, I just want to note that there will be some spatialized audio in a few minutes, so if you have headphones available, I highly recommend you put them on. So this work is really motivated by a few main points. The first being that alt text on the web is often missing or incomplete. And alt text, when present, needs to be brief. So it's very good at giving a high level perspective of an image. For example, that this photo in the upper right is of a busy city street, but it doesn't really capture details. Those details may be best conveyed using a multimodal approach, using different modalities like non-speech audio or haptics. And multimodal approaches like these have been very useful in improving web accessibility, and systems and tools have been developed to automatically create these multimodal renderings of various kinds of graphics. But these systems tend to be a bit focused on one kind of scenario. So one kind of graphic transformed in one way to produce one kind of rendering. And as part of the image project, we needed to produce a variety of kinds of renderings. So we were looking for an open source platform that can support a variety of situations easily. Situations like encountering a graphic that is this photo in the upper right corner, but also an embedded map or a pie chart of COVID data. And then conveying that as non-speech or spatialized audio, but also using the sense of touch. So something like kinesthetic haptics that can guide a user's hand across the image, or a raised pin array. So we quickly realized that we would need to make our own platform to do this the way we wanted. And we wanted to make a platform that can be extended and used by other people for their own kinds of goals. So what I'm hoping to show today is how you can use the image architecture for your own purposes by going through this example, the busy city street, and how the image framework can be used to transform it into a spatialized audio rendering, one that indicates the large regions of this image and plays a spatialized audio rendering of the outline of each, and then goes through the objects and plays a spatialized ping to indicate their position in the image and also their size. And that rendering sounds like this.
This outdoor photo contains the following outlines of regions: building, car, and signboard. It also contains the following objects or people: 6 people, 2 umbrellas, 2 traffic lights, 4 cars, a bus, and a backpack.
So without further ado, let's talk about the approach with image a little bit. So the architecture really consists of two parts, a client, and our implementation, a browser extension that gets data on the graphic being encountered, and then sends that data to a server, where that server will then process that data to get more useful information. And then we'll have all of that data used to synthesize a set of renderings. And those renderings are then sent back from the server to the client so that they can be displayed to the user. And this is obviously a simplification, and the actual image architecture looks more like this. The server is expanded to include three main types of modules. Um, and this may seem a little overwhelming at first, but I'm going to be stepping through all of this and all of these modules. And I also just want to note that all of these modules are Docker services communicating with each other over HTTP, with one exception that I will point out when we get there. So let's start at the beginning. The client, the browser extension. A user encounters this photo on the web and wants to get multimodal representations of it. So the client will produce a blob containing data about it shown on the left. And that JSON blob will contain some generic information about the request itself, a UUID, a timestamp it was produced at, the page it was produced from. then some information about the graphic. So the actual blob of the image itself, its dimensions, the image tag it was contained in on the page, and then some more image specific information. So a set of capabilities, which are different user preferences or available haptic hardware used to determine what kind of renderings can be produced. In this case, default options and no haptic hardware. And then a list of renderers, which are these data formats that the client supports to actually display renderings as. So as text, as a simple audio file that can be played through, and as a segmented audio file with annotations allowing the user to go to specific meaningful segments. And all of this information is sent to the server where it first goes to an orchestrator. So this orchestrator validates the data that comes in and then looks for the other modules that will need to be run. So those modules are either preprocessors, which do that processing task, or handlers that do the synthesis work. And all of these preprocessors and handlers are found by looking for running containers that have either a preprocessor or handler label. And once the orchestrator gets all of these, it will then start sending the data to the preprocessors, where each of these preprocessors are wrapped around something like a machine learning model or a third-party service, something to get more information about this data that was collected. And each preprocessor also includes a priority number that indicates the order in which it should run, and an output format, which is advertised so that other preprocessors and handlers can actually use the data it produces. So in our example, that collected data from the client is first sent to a content categorizer, which identifies this as being a photograph, and a map information preprocessor, which quickly realizes that this isn't a map. So it exits almost immediately with a code indicating that it can produce no content for this. Next, it will move on to this graphic tagger in the second group, which has access to that content categorizer information to realize, well, this is a photograph I can run. And when it runs, it realizes that this is an outdoor photo. So after that runs, all of that data from the first and second group are sent to this third group of a semantic segmentation preprocessor and an object detection preprocessor, which find regions and objects in this photo. So after all of the preprocessors run, all of this data and the data from the client are sent to a set of handlers, which can use these other Docker containers called services to perform very general tasks that are replicated across all of these handlers. And in this example, the handler uses two of these services. So that data comes in from the preprocessors and is used to generate text describing the image. So something like this outdoor photo contains the following outlines of regions, etc. And that text is then sent over HTTP to this TTS service, which will convert these text segments into speech, the speech you heard earlier. That is sent back to the handler, where that information is used to annotate the data it's already produced. And all of that is then sent over OSC, Open Sound Control, to a Super Collider service. And OSC is just used here because Super Collider doesn't support HTTP. And the Super Collider service will then generate additional non-speech audio, those spatialized outlines and pings that you heard earlier. And then we'll spatialize all of this audio, the ones it generates and the others, and sends all of that back to the handler, where it's used to create renderings and return it. So that all of that data then goes back to the client where the renderings are displayed. So that text description is shown, but then also there is the audio you heard earlier with those annotations, so a user can open a drop-down menu and select, well, I want to hear where the cars are in this image. So I click here and then I can hear the cars or go to the people. So I hope this helped show you how you can use the image architecture for your own work. If you want to learn more about image, please visit our website at image.a11y.mcgill.ca, where you can find our browser extension and our repositories, one for the browser extension licensed under the GPL, and one for all of the server components that were discussed here today and more, which are licensed under the AGPL. Thank you.